Hello everyone, our group is Maddie, Sequoia, and Neela, and our study is Wreckage to Regrowth, observing positive post-hurricane recovery and secondary succession in Point Pleasant Park, Halifax.
Point Pleasant Park is a public park owned by Canada, located in Halifax, Nova Scotia, consisting of around 75 hectares of land in the unceded territory of the Mi'kmaq people. The park's forest type is primarily made up of Acadian species like the red spruce and the red maple, along with the ground and soil consisting of many different rock types. Point Pleasant Park is important to the Mi'kmaq people because before the land was turned into a public park, it belonged to the Mi'kmaq community. The park holds both spiritual and cultural significance. The Mi'kmaq Nation is known for their practices and respect for the land while focusing on sustainable land growth for thousands of years. Because of the urbanization done to the park in 1749, the park was challenged in facing a double negative. Because the urbanization not only had effects on the ecosystem of the park, but also on the indigenous people that have cared for the land long before us. And by doing such, we not only disrupt the balance that was cared for and made, but also negatively impact and disregard the relationship between the land and the Mi'kmaq people. In 2003, the park was struck by Hurricane Juan, which caused large amounts of damage to the park with 151 km/h winds. But it was said by researchers like Burley et al. That the damage from the hurricane could be beneficial and was actually a positive way for the park to reset its succession. The objectives of this study in PPP are to examine how the forest has changed overall structure over time since 2003, and finding changes in tree density with specific help from the red spruce and the red maple, along with examining park species richness and biodiversity changes. This research is significant because by using the damage done by Hurricane Juan, PPP researchers have been given the opportunity to survey the park by recording the new growth in hopes of positive post-hurricane recovery management, with help from field assessments and reviewing aerial photos. This study focuses on answering proposed research questions around total tree density and species richness in the park from the years 2004 to 2024, with data gaps in 2005, 2007, 2016, and 2020 because of hurricanes and COVID-19. Our hypotheses HO for total tree density, red spruce density, red maple density, and species richness is that PPP will not change from 2004 to 2024. And our alternate hypotheses, HA, is tree density, red spruce density, red maple density, and species richness in PPP will increase over time and recover after Hurricane Juan.
When the data was collected for this study, sampling sites were randomly chosen from 30 locations within Point Pleasant Park that had similar elevations, topography, and pre-hurricane species composition. Subsections within each site were labeled as disturbed, with less than 20% canopy cover, or intact, with more than 80% canopy cover. 1 by 1 meter squares, evenly surrounded by a 10 by 10 meter square, were permanently marked at random inside each subsection. These were then monitored in the years following the destruction from the hurricane. Each year, each species of the plants at the sites were recorded and identified using local field guides. The number of each species present was then tallied up and later used as a metric. Plants were also classified as native or non-native. In order to ensure all species were recorded, each plot was visited repeatedly throughout the growing season of each year. The number of different species in each area was later counted to get the species richness metric, and the abundance of each species in each area was used to calculate the density of each species in each site. Linear regression analysis was used to measure overall forest community change, dominant species density change, and the change in species richness, due to its ability to easily and clearly show the trends in discrete datasets. The diameter at breast height in all trees in the study was measured using DBH tape. Taking this measurement allows the data collected to be compatible and therefore comparable with the forest industry measurements.
This graph shows the change in total tree density per 400 meters square in PPPNS from 2004 to 2024 with data gaps in the stated years. The data findings support HA that tree density in PPP has increased over time and continues to recover from 2003 Hurricane Juan. The recession line of the graph has a slope of 8.7 and an R2 value of 0.49, meaning that about 49% of density differences in PPP can be explained by time, which supports the research done in 2008 by Burley et al., saying that weather like hurricanes reset succession in parks, making room for new and stronger growth. The leftover percent of 51 tells us that there could be other factors involved like storms or hurricanes. This can be seen by density fluctuations throughout the years, like in 2015 where we see a large increase in density that drops after 2016 Hurricane Matthew. Although hurricanes may cause damage to the land, the look of the torn apart area is often worse than the actual damage that was done ecologically. This study was performed to track increases or decreases in total tree density in Point Pleasant Park after Hurricane Juan. Based on the collected data, PPP will experience secondary succession and is predicted to return to its pre-2003 hurricane conditions and reach its climax community. Therefore, we can reject our null hypothesis for total tree density. This is important because, as the data shows, if a disturbance or disaster were to happen, the environment could recover, which could help in future research and conservation methods.
This data was collected and graphed to discover the effects on tree dominance after Hurricane Juan hit Point Pleasant Park. This was done by measuring the post-hurricane densities of red spruce trees and red maple trees in 2004 to 2024. These densities were measured at 6 sites in Point Pleasant Park, Halifax, Nova Scotia, Canada. It was found that in the recovery from the hurricane, the red spruce showed a gradual increase in density in the 20 years following Hurricane Juan, though this R-squared value of 0.1228 is low, which points to high levels of variability. In the red maple, however, we see a steeper slope of 2.565. This indicates a rapid increase in species density over the years after the hurricane. So we must conclude that yes, the hurricane did have an effect on species dominance at Point Pleasant Park. Before Hurricane Juan, red spruce was the dominant species, but after the hurricane hit, 70% of the trees were lost, and in the following years, we see this shift in dominance from the red spruce to the red maple. The red maple becomes quite abundant on average. From 2004 to 2024, around 5.5 red maples are seen for every red spruce. This is because the red maple has the ability to thrive after disturbances in the environment, such as the hurricane, and this ability led to the dominance seen now. However, in the absence of further disturbances, the red spruce may gradually reobtain dominance over the red maple as the forest moves to its climax community.
Over the 20 years following the devastation caused by Hurricane Juan, species richness has significantly increased. The recession line of the graph has a positive slope of 0.53 and an R-squared value of 0.61. Since this R-squared value is greater than 0.6, it is considered statistically significant in ecology and shows that the majority of the population follows the upward trend that is visible in Figure 3. This supports our hypothesis that species richness would be initially low after the hurricane and increase over time. Species richness is a vital contributor to high levels of biodiversity, which is a key factor in protecting ecosystems that are valuable to humans. Point Pleasant Park is an important Halifax green space that provides many visiting Haligonians with mental and physical health benefits. Increased biodiversity helps increase Point Pleasant's resilience, preserving access to this valuable service. This study was performed to observe the increase or decrease of species richness in the area after a massive disruption, monitoring this aspect of secondary succession in Point Pleasant Park. At each of the replicate sites, researchers documented which species of flora were present and then used this species identity information to determine species richness, creating a metric that could be compared over several years' worth of data. 20 years after the disruption, many plant species present in these areas are now secondary successors and either colonized or recolonized these areas in the years since the hurricane destroyed much of the previous ecosystem. Species richness increased over time as the disturbed ecosystem diversified and additional species were able to disperse into the changed habitat. As the tested sites move closer to achieving a climax community, we predict that the species richness will follow its current trend and continue to climb as the ecosystem diversifies. Once the climax community is reached, however, species richness will likely increase at a slower rate, since the community will become more stable and previously established species will have a competitive advantage over newcomers.
Human activity has effects on urban parks and their succession. The noise and presence of humans and their pets can greatly disturb wildlife inhabiting an urban park, like Point Pleasant, causing stress or displacement. Nearby pollution from vehicle emissions or infrastructure runoff can cause harm in many ways. For example, pollution is a lead cause to environmental harm, and runoff can encourage or discourage plant growth, both in negative ways in respect to succession. Human intervention, such as protection, can actually have negative consequences on the environment and succession. Protection like fire suppression can alter successional pathways away from their natural course. Human actions can cause plants to grow out of their natural range. Things like artificial moisture conditions or the urban heat effect all change the progression of plant communities. Ultimately, due to human activity, urban parks can experience delayed or accelerated succession, as well as altered successionary pathways.
This study on succession in Point Pleasant Park following Hurricane Juan could be used as a study model for other environments that have gone through disturbances like hurricanes or other damages to show the natural effects a park community undergoes post-natural disaster. One method you could include for managing disturbances could be the restoration of native species. This was shown in the PBP study because this study focuses on promoting growth from native Acadian species like the red maple and the red spruce. And another method I would include or keep was the monitoring of the area long-term in order to track new growth patterns. Because this study did exactly that, it was able to track the recovery process of the affected area for 20 years to ensure positive changes in the ecosystem.
Climate change is predicted to increase both the frequency and intensity of extreme weather events, which could dramatically impact the pattern of ecosystem recovery. As the number and severity of ecosystem disturbances increase, the more delays and resets that succession will experience. With enough setbacks, this could prevent Point Pleasant Park from reaching its full potential as a climax community. Climate change may also change what species are involved in that climax community, as warming temperatures shift both plant and animal habitat ranges. Since Point Pleasant Park is located on a fairly low peninsula, it is also at risk of sea level rise and mass flooding, which would result in dramatic ecosystem changes throughout the park.
Point Pleasant Park is an urban park, and this means that human activity can affect succession. Paths throughout the park can affect seed dispersal and overall forest growth. Pollution can reduce growth rate, increase susceptibility to pests and disease, have negative effects on soil health, and much more. Being an urban park, it can also experience delayed or accelerated succession, as well as altered pathways in succession, as discussed in the results question. But being an urban park doesn't mean that the forest can't recover, it just means that the forest will recover differently. After an examination of species density and species richness recorded at multiple sites within the park after the hurricane's damage, the recovery of the forest can be seen as it moves towards its climax community. Observations suggest that while the forest community has changed, it is recovering, but has not yet reached its climax. Assuming the environment is allowed to follow its course with no further disruption, this forest will continue to recover and grow ever closer to its climax. As this approaches, a shift in dominance back to the red spruce may occur. Species richness will continue to rise until a stabilization is met, and the forest will reach a recovery similar to that of the forest before. It is important to look to indigenous practices to help understand the environment and take away ideas. There is an indigenous practice of burning, and this is where small controlled fires are intentionally set to mimic the natural fire cycle and promote healthy forest regeneration, as well as reduce the fuel load for possibly much larger wildfires. A takeaway from this practice is that while the ecosystem was destroyed, it is still able to regrow and become stronger for it.
We would like to thank the past student data collectors from 2004 to 2024 of the course, along with the instructors Christine and Allison and our lab TA Abigail. Point Pleasant Park is in the unceded territory of the Mi'kmaq people, therefore we would also like to give our acknowledgments to the Mi'kmaq community who have been looking after the land for thousands of years, along with giving Point Pleasant Park its original name, Amtukati.